In this demonstration, we're going to look at the effect of temperature on the equilibrium of the reaction of dinitrogen tetroxide decomposing into nitrogen dioxide. Dinitrogen tetroxide is a colorless gas, colorless liquid, and when it decomposes into nitrogen dioxide, which is a brownish red color. In front of us right here, we have 3 tubes at the same pressure of the N2O4 in there. Dinitrogen tetroxide, by the way, is used as an oxidizer on some rocket propellant combinations. And what we're going to do is we're going to start out and we're going to have this particular one is going to have some hot tap water in it, probably about 50 degrees Celsius. The center one we're going to leave right here at room temperature, and then we're going to put this one in a beaker with some liquid nitrogen. And we're going to see the effect of the temperature on the color, which is going to be able to indicate to us whether or not the reaction is endo or exothermic. So we're going to start out, Noah, if you fill that beaker with some hot tap water. Again, the temperature will probably be about 50 degrees Celsius with this tap water. And in the other beaker, he's going to pour some liquid nitrogen, which is going to be about 77 degrees Kelvin, or about minus 200 Celsius. And you'll notice that the liquid nitrogen is boiling because the beaker and the table are at room temperature. And it's okay if it's not full, it will be just fine. And now go ahead and put the one tube in the hot tap water. We'll just let it sit there. And put the other one in the nitrogen. And we'll wait until we get a little bit of color contrast. And hopefully that you can see already that the one in the liquid nitrogen is becoming much less of a brown color. And if we compare this one to the one at room temperature, the one at the hot tap water temperature has become much darker. Now we're going to try to surmise whether or not the reaction is endo or exothermic based on the observation. Based on the observation that we're seeing, as the temperature goes up, we get more brown color. In other words, at a higher temperature, it's favoring the formation of the NO2. Does that mean the reaction is endo or exothermic? Well, if the reaction is endothermic, that would be like writing the word heat as a reactant. If the reaction is endothermic and we put in heat, in indication of this one at the higher temperature right here, Le Chatelier's principle says that it should shift the equilibrium toward the right, toward the brownish red. And that's exactly what we're seeing right here. It's getting darker at the higher temperatures, got much lighter at the lower temperatures. In fact, we'll even see some bluish green liquid in there that's indicative of some N2O3 in that tube as well, but the brown colors completely went away. So we conclude that this particular reaction is endothermic based on the color change with respect to temperature.